Welcome to lesson 3.5, where we're going to talk about derivatives of inverse functions. Now, before we talk about derivatives of inverse functions, we should probably review what an inverse function is. And that's in these two paragraphs at the top. So it says, at the right are the graphs of a function f of x. So right here is the graph of f of x. Looks like it's probably a cube root, but it doesn't really matter. And then here's the graph of its inverse function, f inverse of x. And then here's a couple things that you should remember. One, remember that if the graph of f contains the point a comma b, then the graph of f inverse contains the point b comma a. That's how inverses work. You take the points on one, flip them, and it becomes the points on the other. Number two, also the graph of f inverse is a reflection of the graph of f across the diagonal line y equals x. And that will work for any inverses. For example, if I take the parabola, I'm only going to take one side of it. And we know that inverse of x squared is a square root. Square root looks like that. If I were to put them both on the same one, they are reflections across that diagonal line. That's the definition of what an inverse is and how you can see it on the graph. Now, from this graph and what we've remembered, we're going to look for a relationship between the slope of the graph of f at a comma b. So let's look at a comma b. Looks like the slope is going to be about like that. Slope or derivative, remember, is another word for instantaneous slope. And the slope of the graph of f inverse at b comma a. Oh, there we go. There's that slope. Now, do you notice anything that these lines have in common? It might be a little hard to see. So instead, I'm going to pick the intercepts right here and do it again. Let's do this one. So the graph of this going to be about like that. And then the graph of the inverse is going to be about like that. What do you notice about the blue and the purple lines? Well, they're perpendicular. And if you remember, perpendicular slopes are opposite reciprocals. So if one slope is 2/3, the perpendicular slope is going to be -3/2, opposite reciprocals. Now, let's dive into this a little bit more, because that's only the blue and the purple lines. So let's try a little bit more of an example. Let's do number 1. Let f of x equals square root of x. Sketch the graph first off. So square root of x is 0. 1, and then the square root of 4 is 2. If you don't remember that, you can look back at your parent graphs in chapter 0. Now it says to find f inverse of x. Remember, to find the inverse, you're going to flip the points or reflect across this diagonal line. So we're just going to do a reflection. That's the easiest. Like that. So this is f of x. This is f inverse of x. So there it is on the graph. We need to now find the equation. So let's remember how we find equation of inverses. You switch the f of x to a y. Flip the x and the y. And then solve for y. That's how we find inverse equations. So we've got y equals x squared. And we should already know that. The inverse of square root is squaring. But it says we must list a domain restriction. Notice on this graph, I didn't show the whole graph. It's only for x greater than 0. So that's an important point. And let's say this is f inverse. Okay. I have the sketch of both of them in C. Now, I'm going to differentiate both of them. So I have f of x equals square root of x. F inverse of x equals x squared. Let's take the derivative. So f of x, let's rewrite as x to the 1/2. So if I take f prime of x, that's going to be 1/2 x to the negative 1/2, or 1 over 2 square root of x. Because that negative 1/2, bring it down to the denominator to make it positive, and then turn it back into a root. Now I'm going to take the derivative of the inverse, which is 2x. Okay, there's my derivatives. Next, find the slope of the graph of f of x at 4, 2. So let's f prime of 4, 1 over 2 root of 4, which is going to be 1/4. And find the slope of the graph of f inverse at 2, 4. Notice I flipped the points. So that's going to be 2 times 2. So f inverse prime of 2 equals 4. Now, that was a lot of information to come to this final conclusion, which is, what conclusion can we make about the slopes? The slopes of inverse functions are reciprocals of each other. Which, when we come back up to the original graph, we can start to see. If the slope of this is like 1 over 5, then looks like the slope of this is 5 over 1. This, perpendicular ones, are reciprocals. So, it wasn't quite what we had originally thought. They're not opposite reciprocals. They're just reciprocals of each other. Now, this should make some intuitive sense because we know that the slope is change in y over change in x. That's what you've known since 7th grade. And if we're switching x and y for an inverse function, then the slope of the inverse would be change in x over change in y, the reciprocal. So that's how we find derivatives of inverse functions. In the next video, we'll do a couple example problems.